Hello viewers, welcome everyone. This is Ankita here, and today we are going to talk about or see about the number theory and its real life applications. So, before moving forward, as we all know that number theory covers the vast portion of mathematics. So, considering this, a German mathematician Carl Friedrich make a statement that mathematics is the queen of science and number theory is the queen of mathematics. Okay, so let's see what the queen of mathematics says. So, here is the basic definition of number theory, which says that number theory is the branch of pure mathematics devoted to the study of natural numbers and the integers. It is the study of set of positive whole numbers which are usually called the set of natural numbers. The number theory helps to discover interesting relationships between different sorts of numbers and to prove that these are true. Number theory is partially experimental and partially theoretical. Experimental parts leads to the questions and suggest way to answer, while the theoretical part tries to devise an argument which gives a concluding answer to a question. The number theory is also divided in some subheadings. The first one is elementary number theory, in which integers are studied without use of techniques from another mathematical field. The next one is algebraic number theory, in which the concept of number is expanded to the algebraic numbers, which are roots of the polynomial with rational coefficient. The further one is analytic number theory. It is a branch of a number theory that uses methods for mathematical analysis to prove theorems in number theory. The next one is geometric number theory. In geometric number theory, number of theoretical problems are studied by the use of geometric methods. And the last but not the least one, probabilistic number theory, which explicitly uses probability to answer the questions of number theory. Okay, this is all about the number theory. Now moving towards the application. Here is one of the application of number theory in real life. Suppose you are a prey A and there is a predator P. For every living being, there is something called hibernation period H. For human being, it is 12 hours, which basically means that you can sleep for H time and you can stay awake for another H time. Now suppose you know the hibernation period of your predator is X, then what hibernation period will you choose for yourself so that you minimize the chance of getting hunted? So suppose you have some maximum hibernation period M, you choose some Y from 0 to M. Now suppose X and Y have some GCD, that is greatest common divisor. Maximum time you could stay alive is equals to X into Y divided by GCD. You have to maximize this over 0 to M, hence done. By using this, you can calculate the hibernation period for yourself so that you minimize the chance of getting hunted. Now we will see the next application of number theory. Do you ever wonder about how our online transactions are so safe and secure? Well, this is all because of the cryptography. The most important application of number theory is that it is the key of foundation of cryptography. Well, in 1970s, a trio of mathematicians, Rivers, Shamir and Ederman at MIT were able to use Fermat's little theorem to come up with the public key inscription scheme known as RSA algorithm, which is standard inscription method used for online transactions today. The RSA algorithm consists of an inscription procedure which is publicly known. Well, the whole inscription works due to the number theory. As a result of security of transactions is ensured. And the second is a description procedure which is only known to the sender and the receiver. Now we will see how it works or what's the working process. When we send information by electronics means such as ATM, the computer converts our information, the message we want to send, into a single number called the number representing our message M. Here's the key idea behind the RSA scheme. to find numbers e and d for inscription and description such that m to the power e whole to the power d is equals to m to the power d whole to the power e equals to m mod n. To carry out the RSA inscription, when we then use two large prime numbers. Prime numbers around 100 digits should be sufficient. Call this prime p and q for the product of the two primes and call this number n so that n equals to p into q. Also from the number z, which is equals to p minus 1 into q minus 1. Here the number z is important because it represents how many numbers between 1 and n do not share factors with n. To find such number, we can recall Fermat's little theorem, which suggests that for any prime p, m to the power p is equals to m mod p. Now, if we pick e to be any prime number less than z, then is not a divisor of z. That is not a divisor of z. Then we are able to find a number d such that d into e equals to 1 mod z. We'll show that once we have found d and e in this manner, then d into e equals to 1 mod z or equivalently d into e equals to 1 mod p minus 1 into q minus 1, which implies m to the power e whole to the power d is equals to m to the power d whole to the power e, which then equals to m mod n. So we encode the message using the inscription number e, send the encoded message together with e and n over the public domain while keeping d known only to the sender and the receiver. This ensures the security of message since a hacker would calculate the factors of n, the product of two large prime numbers, in order to find d, which would take a modern computer many decades to complete. The prime numbers p and q used to calculate n and are changed sufficiently often to ensure that the RSA algorithm is secure. Here's the diagram representing the process used in RSA for encrypting and decrypting our message. Here first the message is converted into a number denoted as m. Then two large numbers p and q are used. Use p and q to calculate the numbers e and d, the inscription and description scheme. Then here's the Fermat little theorem comes into play. We use it to calculate suitable numbers e and d. Then we encode m using e and send the encoded message along with e by public channels, while send d the description scheme by a private channel. Here a hacker must factor the product of p and q in order to decode the message. This is the security of RSA. Then after, the target receives and decodes the encrypted message with confidence of security. Well, the main reason the RSA algorithm is so strong is the fact that in order to break it, it's necessary to find the prime factors of genetic numbers, a number with around 200 digits. This might take a supercomputer many decades to complete. Hence, our online transactions are so much safe and secure. Well, this is all about the cryptography. Now, here are my references. Thanks for watching.